things that you need to do today in addition to your exit ticket in order for you to be counted as present. Okay, that's very important. All right. Now we will talk about a couple of things. And for those of you who were not here yesterday, you will need to go in and watch the video, okay? Because we're talking about ionic bonds. We're going to finish that up today, okay? And like I said yesterday, this video is beneficial if you need it, okay? However, it's not going to be something that is just, you know, oh, I gotta watch this, if you get what I'm saying, okay? So yesterday we went over transition metals. We talked about transition metals. My teacher radar went off a little bit, and new person just submitted theirs. My teacher radar went off a little bit, and I realized you guys were probably going to get overwhelmed. So I didn't want to I didn't want you to, you know, get in that situation. With the progress reports, okay? If your grade is less than a 30, if your grade is less than a 50, if your grade is right at a 50, okay, and you have instructed and told me that you have informed your parents, that better be the truth, because they're going to be getting contacted here pretty soon. Okay, so it's going to be it's going to be important for you to do that, because you don't want me calling home and saying, hey, well, such and such said that they let you know that they have a 12, or they let you know that they have a 50, and your people be like, yeah, no, they didn't. Okay, so it's very important for you to make sure that that's something that you're doing. All right. Now, with regards to this, we're going to talk about polyatomics today, and it is going to be important for you to learn this, because this is a topic that is going to apply to our future, and it's super, super easy. So if you just pay attention today, okay, and we'll talk about different ways that we're going to use these in the future. But if you pay attention to today and when we review it and things like that, it's not going to be hard for you in the future. It's very easy, but when you see them, they look very intimidating. Okay, so if you have C2H3O2 and you're like, what in the heck is that? Well, actually, it basically is treated like it's an atom. Okay, and so we're going to go through and look at all those things. Okay. So when we do this, okay, our stuff that we did yesterday, we did page 1 of that web quest activity. Okay, we did page 1. Now we need to continue to go through and do that today, and I'm going to give you some of your assignments that you need to make sure that you, or some of it that you need to make sure that you go in and do. Lastly, your attendance check will be done today. Okay, so we skipped it yesterday because we didn't learn that stuff. So we're going to go through and look at it. Now, to begin with, we're going to finish the transition metals slides. Okay, so if you guys were here yesterday, you can go ahead and open those notes. If you were not here yesterday, you can, you know, however you do notes is fine. But if you were not here yesterday, then we're starting a little bit in front of where you would be on the notes and things like that. So we talked about Roman numerals. We talked about swapping and dropping. Okay, swapping and dropping is simple, but again, it's something that we have to make sure that we pay attention to. Okay, now turning the formula into a name for ionics is easy as crap. Well, in general, naming is easy. Okay, but we're going to do some like graphic organizers to kind of say, well, if it's this, then this, but we got to get that information first. So if a compound has a transition metal, that's the hardest one to name. Okay, it's the hardest one to name. All right, and so what you're going to see is lead and tin are also examples. Okay, so tin and lead, you'd have PB30 something. Okay, they are they're not in the transition metal area. Okay, but they are technically considered, because they have weird characteristics, as things that you have to use Roman numerals for. So there are two, zinc and silver, in the transition metals you don't need that for, and lead and tin you do, that are outside. Those are the only exceptions. Okay, so before we get to this, there's a couple of things that we have to know. Okay, so the first thing is that you will always, always, always know the charge of the anion. Okay, and that the entire compound has to be zero. Okay, the charge has to be zero. If it is not zero, you are wrong. I'm going to show you how to do this, but the pluses have to equal out the negatives. They've got to counteract each other, or it's incorrect. It's not right. Okay, so anions don't change charges. Every fluorine in the world is going to be -1. Every oxygen is going to be a -2. Every nitrogen is going to be a -3, period, point blank. So what you have to be able to figure out is maybe the charge of a transition metal, okay? And that's going to kind of be what we look at. So when we do this, before we get to the transition metals, okay, the rules for naming, okay, ionics are very easy, okay? For some reason, y'all find ionics hard and covalence easy, which I don't understand. But so what you have is, let's say we were using salt the other day, right? So NaCl, all right? The general rules are that you write the element, the first element. So if it's nitrogen, it's not gonna be nitrogen, but if it's calcium, magnesium, rubidium, strontium, whatever, okay, you write it out. Then you write out the second element, okay, plus IDE at the end. Let me write that so it's actually legible. IDE at the end, okay? So fluoride, iodide, carbide, nitride, okay? IDE at the end. So all you write element, element, ide, okay? That's ionics in general. So we're gonna learn, that's basically the ionics in general. Now, the difference, transition metals are difficult, okay? So when you figure this out, you have to be able to go through and tell me what exactly is going on. Now, we went over yesterday that you read this as tin 4 oxide, okay? Or what was the other one? Cobalt 2 chloride. That's how you read it. Now, what you're going to have to see is that you first draw a T-chart, okay? Now, I hate doing this. And if you don't have to draw the T-chart, well, then you don't need to. But we are basically reversing the swapping and dropping. Okay, we're basically reversing the swapping and dropping. All right, so the key thing that we have to do here is we have to make sure that you are basically going to be set up in a specific way. They got to equal each other, okay? Always going to have a charge of 0. So draw out the T-chart, write out the chemical symbols, okay? And then calculate the charge and calculate the charge. I'm going to show you how to do this. So this is one of my favorite things to play with, okay? I make big, loud, and well, not really loud, but really, really high heat, violent reactions with this. And I bought some. It's coming. Okay. So what we're what we're gonna do is first off, you have to write these in here. Okay. Now you got to make sure that you put the subscripts in. T-charts are a pain in the butt. All right, but the next step is you have to tell what your total charge is. Okay, so if you don't remember how to do charge or you didn't learn charge, I told you this stuff is going to build on itself. Okay, so every oxygen is in group 16. Okay, it's in group 16, which means its charge is -2. Okay, so basically, if you have 3 oxygens, you got oxygen, oxygen, and oxygen. Okay, each one of those has a -2 charge. So it would be -2 minus 2 is -4, minus 2 is -6. Okay. However, we just save time and effort, we just multiply it. So you multiply the charge by the number of oxygens that you have. Okay. So what we're trying to do here is we are trying to get the total number that we have to have over here in order to be 0. We want 0. It's opposite of class. You don't want 0. Okay. So since we have that this is a -6, we know that over here we have to have a +6 or it's not going to work. Okay. It's not going to work. 6 minus 6 is 0. You got to have the same numbers. Okay. So when we do this, you know that you have to have 6. What you have to be able to put in here is you have to be able to say, well, we got 2 irons. Okay, we have 2 irons, which means that each one of these, 2 of those things has to equal 6. Well, guess what? 3 plus 3 equals 6. All right, so when you figure what this is, you can name it. Okay, once you figure out what this is, you can name it. So you write iron, 3, okay, and then you don't have to do anything with the oxygen. You write oxide, iron 3 oxide. All right, this is as hard as naming gets. Okay, because we talked about if you have something like this, all you do is you write barium and then you write chloride. It's very easy. The only thing with the transition metals, okay, is that you have to put the Roman numerals in there. So you have to figure out what iron is, okay, what its charge is. So this is difficult, all right, for some people, okay? Some people can just see it, all right, and it just depends on what you're going through and looking at. Okay, your last step is to name it. So you named it, iron 3 oxide, all right? Now let's look at here. You have tin. Okay, we talked about the fact that tin and tin-4 is very common. Okay, I take a vitamin because I'm old, and one of it says from tin oxide, but it didn't say like tin-4 oxide or whatever it is. So I don't know which tin oxide it is. I'm assuming that it's SN 2O, tin-2 oxide, but I don't know. Anyway, so I don't know what I'm putting in my body, but first step is you got to figure out what the anion is. Okay, now this one's easy because there's only one tin. Okay, there's only one tin, so whatever the charge is over here, that 10 is going to be that charge over here. Okay, so when we do this, get out of here, you got oxygen again, which is you have 3 of them total, and each one of those is -2. Okay, and so -2 times 3 is -6. Okay, so what does that mean that the 10 has to be? In the chat, I know y'all have access to the PowerPoint. In the chat, tell me how you what number is 10? What charge is 10? Well, it is positive, right? But positive what? Did I say 10? I'm sorry. So if I said 10, I was wrong. Okay, I was reading this email from this lady that works in CMS that is getting on my nerves. I'm sorry. So this is -6. So what does this have to be over here on this side? Okay, in order to equal 0. I'm sorry. I messed it up. I messed it up. This is what I get for trying to multitask. There it is. All right, a couple of people put it. Okay, so hopefully you're not going to be confused because I'm screwing stuff up. All right, so I'm sorry. So this is -6. This has to be +6. Okay, so yeah, right. So the equation is the answer basically. So when you're going to go through, whoops, clear. There we go. Okay, 6 minus 6 is 0. Okay, so the next step is to say, well, the charge of 10 is 6. Remember, we said charges can be really high. Okay, so you have 10. There it is. 6 oxide. Okay, guys, if you can do this, you can name any ionic. We're getting ready to go over polyatomics, and they look crazy, but they're easy as heck. Okay, so if you can do this, basically naming ionics should be good for you. All right, pay attention to this, pay attention to polyatomics, and we all good. So let's see if we can do number 1, lead and chlorine. Let's see if we can do number 1. All right, put it in the chat. Oh, I'm sorry, I didn't give you a time frame. We'll give you 3 minutes. I see, I know some people have already answered. So Stephanie, what would you name it? You got that part right. So what would you name it? Sweet, Jessica. Jessica did all of them. Yep, that's right, Stephanie. Yeah, we're getting it. We getting it. We getting
Was
it.
I supposed to do only one, or did I do something wrong?
Well, we were only doing number one, but no, you can do
Oh,
all of them. I'll take that. You get 10 right? Yep. Sweet. All right, one more minute. All right, so we're going to go through it and we're going to see hopefully that we are going through and making a real concerted effort to learn this stuff. We're doing really well. So first of all right, if we do our T-chart, I'm getting sick of this orange color, so that's going to be switched up here. Okay, but you have Cl2. Okay, so you have -1 times 2 gives you -2. Okay, you have two of the particles, and that charge is -1. If you're having problems with charges, then you have to make sure that you are going through and looking at that. Now, yep, that's right. So it would be lead. Okay, and so this is -2, which means this has to be +2. So you have lead 2 chloride. Okay, lead 2 chloride. Now, don't let a week go by and y'all forget what these darn Roman numerals mean. I know for a fact somebody's still going to do it. I'm telling you it's coming. So when it comes, I'm going to tell you, hey, remember I said that? The Roman numerals are charges. Okay, Roman numerals are charges. Now, let's go through the polyatomics. And polyatomics are super easy, but they're also super intimidating. Okay, they're super easy, but they're also super intimidating. Okay, and so what you're going to see is polyatomics. What does poly mean? Poly means multiple. Okay, so polytheistic. The Greeks were for many years polytheistic. They believed in multiple different gods. Romans, pagans, all kinds of stuff. And monotheism is more a recent thing historically. You know, I also was a history major. I am just an overall nerd, you know. But the point is, polyatomic means multiple ions that behave as though they're one thing. Okay, so some of these you may have heard of. All right, and so you have binary and ternary compounds, which is what we did yesterday. Okay, and the difference is going to be like a NaCl versus an Na2CO3, okay, which is going to be what we talk about today. All right, so shoot, in my estimation, being a nerd ain't. I used to be like, I'm not this smart. The heck with it. I'm smart as heck. I like it. Okay, and I'm a nerd. I was being a nerd earlier before y'all got in here. So up to this point, we've been talking about binaries. Okay, Binary compounds means two. Okay, so if you binary code, computer code 0101000100, I probably cussed y'all out. I don't know what that is. But the point is, it's either an open circuit or a closed circuit. All right. What we're going to look at, oops, binary elements are, binary compounds are cool, but polyatomics are also cool. Okay. So when you see this, okay, I'm going to show you something like sodium acetate. And you're going to look at it and go, yeah, no. However, it's still just two pieces that you have to use. We're not using these big giant compounds that have 50, 50 different atoms in it, okay? So a polyatomic cannot be broken up. It's going to be stuck together, all right? And so they look weird. This one or two extra elements in there, okay, and they look a little weird, all right? So it operates as a whole. Now, you can Google a list of polyatomics, okay, and many times I'll say, hey, just look. So you could say polyatomic elements, and it'll show you their charges, and it'll show you all this kind of stuff, but it's on your reference table, okay? So if at some point you say, Mr. Kuhn, man, listen, I don't know how to find the charge of carbonate. Half of these I don't have memorized. And the reason for that is they are on your reference table. They are literally given to you. Okay? So when you go to your reference table and you go to page 7, I hope it's still page 7. I don't look stupid. Page 7. There's a list of all of the polyatomic ions. Okay? Not all of them. All the ones we're going to use. So NH4 or BrO3 behave as though it's one atom. The best thing about this, here's acetate. Remember I said you were going to hate acetate? Okay? The best thing about this is if you look closely, it literally gives you the charge. So chlorate is -1. Perchlorate, chlorate is -1. Chlorite is -1. Hypochlorite. All this stuff is made in bleach. It's chlorine, basically. Iodate, -1. Permanganate, he blows stuff up. -1. Okay? So these type of things, it literally tells you. Let's go to something that doesn't have -1. Look, there's carbonate. So if you say, Mr. Kuhn, what's the charge of carbonate? I'm going to look at you. Say page 7. -2. You're going to swap and drop this, and the rules are basically the same. Okay? The rules are basically the same for that. So let's go here, check the chat. So you do not break these apart. All right? Check it out. So there are only 2 exceptions to this. Cyanide and hydroxide are the only 2 exceptions that are not with an 8 or an ite. So cyanide, highly toxic, poisonous. Okay, if you see in the movies, like the spies, they have the detachable little pill that's in their mouth, and they crunch on it and they go, and they die. That's a cyanide pill. No, I'm not doing that again. It's on recording.
Yes,
Okay. Hydroxide is OH. It's found in drain cleaner. It's found in a lot of cleaning solutions. It's basic, and we'll talk about that later. Okay. What you're going to look at is polyatomics have more than one capital letter. So the other day we were talking about cobalt, right? You guys are going to look at cobalt and you're going to say, ooh, cobalt. Well, guess what? Carbonate is a little different. Notice that these 2 are beside each other and that they are capital letters. Okay, elements, CO or Li or Mg, elements have one capital letter and then the next letter being a lowercase. So there's a couple of hints to that, all right? Polyatomics are going to just about all end at 8 or ite. Okay, that's going to be a hint. So if you see an 8 or an 8, go to page 7. Okay, 8 or an 8, go to page 7. All right, now, quick, darn it. Here's your list. Okay, I will tell you, I got so much stuff. I got 5 million plays, statistics, history, science, other nerdy crap, no English. Y'all can have that. Okay, all kinds of books, random facts. I don't have this crap in my brain. I know like ammonium and carbonate, but if you say, yeah, thiocyanate, I have no idea. I got to check. Okay, and I'm telling you that. So sulfate, I know because we use it all the time, but these charges are things you will be able to look up. Okay, so check it out. Does it contain a polyatomic ion? Well, zinc oxide. Zinc oxide is nothing. ZNO. Okay. Remember the only exceptions are cyanide and hydroxide. Okay. Sodium carbonate. Baking soda. The baking soda. Whip it. Never mind. So the sodium carbonate, the ATE, is telling you that it is a polyatomic ion. It's Na2CO3. Okay. Nitrogen sulfide. Nope. Lithium sulfite. That ite is weird. We haven't seen no ites. All right. So what you're going to see is that ite means that it is a polyatomic. Okay. Magnesium cyanide. Poison. Polyatomic. Remember that these two guys right here are the exceptions. CN is cyanide and OH is hydroxide. Okay. Then you have silver fluoride is not. So the only ones that we saw in here are these guys. All right. Just going to be something that you need to look at. Now, whoops, I need to erase those things before we go on. All right. Okay. We're doing okay on time anyway. Hey, look, that's what I just did. Now, if you're going to turn the name into the formula, okay, this is what you have to do. You are swapping and dropping. The only difference is you're going to put parentheses around the polyatomic ion. Okay, it's the same thing. So if you have carbonate, which is 2 minus, and you have sodium, which is 1 plus, you put a parentheses around here and you do that. Okay, it's the same thing. So you have Na2CO3. Bam, done, good. And it looks like you're like, ooh, I'm a big chemist. Now look at all these letters. It's 2 things. Okay, so people that don't know this stuff, you go, look, man, I'm doing all this kind of stuff. Look at this. All right, all you're doing is separating them and putting parentheses. You got to put the parentheses or it messes it up. Okay, so magnesium bromate. Okay, I hate clicking slides. I like writing it. I don't know. I guess it's just me being a teacher. So you got Mg2 plus, and you got bromate, which is 1 minus. So if you don't put a parentheses here, you're going to put another number over here. That's wrong. You can never have 2 subscripts beside each other. So put your parentheses and swap it and drop it. Okay? So you have Mg parentheses BrO3 with a little 2 on the outside. Okay? And what that means is, get rid of all this junk. What that means is, if you know anything about math, you don't even really have to, but basically this 2 is applying to this. It's saying that you basically have BrO3 again. Okay, BrO3, BrO3. And that's the same thing we talked about. Magnesium has 2 valence electrons. You're going to give it to one of those. It's the same exact thing that we were doing. Okay, so you do all this junk and you put it there. You do not change anything in the parentheses. BRO2 is different than BRO3. I don't even know if BRO4 exists. I don't think it does. Well, no, it wouldn't. So you cannot change what's in there. You got to keep that stuff the same, okay? Aluminum carbonate is the same thing. You put a parentheses and you stick it in there. Now look at that. That looks impressive. Al2CO33. It's like, yeah, look at me. I'm doing advanced. That's some aluminum and some carbonate. Okay? Pretty cool. All right. And so this is going to lead us to do things later on, which is going to allow us to say something like H2O plus CO2 is going to give you H2CO3. This is why the oceans are dying. That's carbonic acid. If you've heard of ocean acidification, okay, we're putting more carbon dioxide into water, which makes it acidic, okay, that's where partially where acid rain comes from and things like that. So there's chemistry behind a lot of the things that we are talking about, okay? We're not going to do the practice right now. However, check this out. This is the easiest thing you can do. No Roman numerals, no prefixes. We're going to learn about the prefixes later. All you're doing is writing the first thing and the second thing, all right? So if you look at this, this is sodium. Y'all don't know what SO4 is yet. Sulfate. So all you do is you write sodium sulfate, okay? Super, 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 super easy. Super, 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 super easy, okay? So, yeah. Okay, some people are writing, so I'm giving you a second. I'm gonna drink some cold soda. I'm drinking my pinky up. Ready? It wasn't really even that good. It was okay, you know. All right, fancy, fancy. Yep, yep. I make fun of my girl for doing that. She does everything she does has her pinky up. That's why I'll be looking over. She'll be writing, or she'll be doing something on her computer. Like literally everything she does, it's just weird. So if we look at this, I can do this in 7 seconds. Now y'all don't know that this is carbonate, this is sulfate, okay? But you're gonna figure this out, right? And so basically this one is aluminum carbonate, all right? All you gotta do is go and look on page 7. This is copper or cupric sulfate, okay? And they do cupric because they do it, oh God, sulfate. No, not sulfate, sulfate, okay? And then you have lead carbonate. That's all you do. It's really, really, really easy. I just didn't want to shove all this into your brains yesterday along with everything else, okay? So, very easy. Binary, now you know ternary, okay? Very, very, very simple, okay? Now, let's look at this. No time. All right, all right, y'all, some more people. I need some more people to do their progress report thing. So, 2 things that y'all are going to be working on. Okay, the first thing is doing your darn progress report thing. So, I guess 3 things. Okay, the second thing is going to be doing your web quest and naming activity. Okay, now this is not going to let me open this. Hold on, let me go back to Drive. Google has been fighting me all freaking day, and I know they're listening to this. The heck with you, Google. I know y'all listening. Hold on, I got to go all the way to it. There it is. One moment, one moment, one moment, one moment. Okay, really? One moment. They keep messing up my, I think it's this one. All right, so okay. So you should have already done page one. Okay. You should have already done page one. This page. Oh, that's not the whole thing. Now, here's the other parts. Okay. Now, this should not take you very long. All right. This should not take you very long, but you are going to do page two. Okay. Page two, it looks like a lot, admittedly, but ammonium nitrate, sodium hypochlorate, iron phosphate, or excuse me, iron 3 phosphate. So this is going to give you an opportunity to go through and do that. Now, the one thing we did not talk about is something like this, the iron 3 phosphate. So iron is still a transition metal. The transition metal rules apply here. Same here. Okay, so the transition metal, phosphate, PO4 is -3. Iron then has to be +3. So you may have to do your little charts to make sure. So you got to make sure that you are looking for and going into the looking at whether or not that's a transition metal and looking at the names on the periodic table, the reference table. So page 7 is going to be your friend, and 4 and 5 are going to be your friends. Well, y'all won't use 4 and 5 because it's split up on y'all's. So the periodic table and page 7. Okay. So page 2 is the first thing that you're going to do after you do your darn, progress report. Then you're going to do your exit ticket. I have so many windows open. Okay, your exit ticket is right here. All right, name the following 2 compounds. And that is going to open up in about 10 minutes. All right, so realistically, we'll do this, okay? Make sure your progress report is filled out, then do your exit ticket, then you can work on your web quest. All right, let's get it. Also, if you do not do a portion of or do something for the last attendance check, you're going to be angry with me. And I don't care. You will be absent. Do what you're supposed to do. Let's go.